Hi everyone, welcome back. Today we're going to finish up our last section and topic in the Appendix A. So tomorrow you guys have your quiz over sections A.3.1 and A.3.2, which is going to be with your sequences and really looking more at like those geometric sequences. And then on Friday, you guys will have your Chapter A or Appendix A test. It's on the lesson plans too. If you go through and look at the week's already spelled out for what we're going to do. Today, we're going to finish up, like I said, our last little section, and we're actually going to look at sequences and functions, and we're going to kind of compare the two. So to start with, though, we're going to go back and we're just going to look at a sequence and kind of talk about the multiple representations and being able to come up with that explicit and that recursive equation that we want to come up with. So, excuse me. So let's say we have the sequence, sorry guys. We'll go with -5, -1, 3, 7, and then my little dots on the end, which just means that my sequence is going to continue forever. So when it comes to those multiple representations, we want to be able to create a table, a graph, and an equation. So I'm going to start off by making a table. So since we know that it's a sequence, we just kind of use n, and we use t of n for our notation. I wish I could make a straight line some days. Straighten this up a little bit. Okay. We know I'm going to leave a little room to put in my zero term because I know that I'm going to need my zero term in order to come up with my equations. So I'm just going to put a 0 there, and then I'm going to jump to my first, my second, my third, and my fourth number in the sequence, which we're given up here, right? This is my first term, second term, third term, fourth term. So I'm going to go ahead and fill those in. So -5, -1, 3, and 7. So we need to figure out how we are getting from one term to the next. So how am I getting from -5 to -1? I'm adding 4. Yep, good job. And from -1 to -3? You said it. Yep, adding 4. And we're adding 4. Right. So we actually know this is an arithmetic sequence because we're adding to get from one term to the next. So in my sequence, though, I do want to be able to go back to my 0 term. So if I'm adding 4 to go from one term to the next, right? I'm adding 4 to go to here, to go to here, to go to here. If I want to go back, I'm doing just the opposite. So instead of adding 4, I'm going to subtract 4. And so my 0 sequence would be -9. Right? Alrighty. So multiple representations, we got our table. We can make our graph, right? So our graph, we had our little XY coordinates, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Probably didn't make it big enough. 5. Maybe we'll go up a little higher. 6, 7. 5, 6, 7, right. So 0, -9, I didn't make my graph big enough, but 0, -9 be 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say it's right about here. 1, -5, so over 1, and then 1, 2, 3, 4, 5, down 5. 2 is at 3, 2, 3. Sorry, my bad. 2 is at -1. I apologize. 2, -1. At 3, I'm at 3. And at 4, I'm at 7. 1, 2, 3, 4, 5, 6, 7. Right? And since it's a sequence, we know that it is, what was that word? Discrete. Right? Sequences are discrete, which means that we're not going to connect our dots. Our dots are going to be independent. And then now we can talk about coming up with our equations. And there's two different ways to write equations. The first was the explicit equation. Okay. So my explicit equation for a sequence is like T of n equals Cn plus a sub 0. C was our common difference. So how did we get from one term to the next? N is our term number, and a sub 0 was that 0 term in the sequence. So we can come up with, what are we going to have? T of n equals our common difference. How did we get from one term to the next? 4. N is our variable, right? The term that we're trying to find. Plus a sub 0, so negative 9. So that would be our explicit formula. The second formula was called the recursive formula, or the recursive equation. And this is the one where you need to know the previous term in order to figure out the next term. So when we write this one, we always start off with our first term. So T of 1. So what was our first term in the sequence? Our first term was negative 5. So T of 1 equals negative 5. And then we want to go up 1. So it would be our term plus 1 equals, and that is our T of n, because you have to know the term before. So the term before this one, right? Because this is what I'm going to start with. I want to go up 1, so that's where the plus 1 comes from. So this is your previous term. And then what do you do to go from one term to the next? We added 4. And then that would be your recursive formula. Nice? Alrighty. So let's, I'm flying through these, aren't I? So let's look at a sequence versus a function and have some conversation on those. So let's say I have T of n equals 2 times 3 to the n. And let's say I have f of x equals 2 times 3 to the x. So these look quite similar to each other, but we know that through our notation that they're a little bit different. So since I have T of n, we know that we use that notation to signify that this one is a sequence. And we know that sequences are discrete, right? So they're right. And then f of x, that f of x is telling us that we have a function. And we remember that when we have a function and a function, we connect our dots because it includes everything in between. And we say that this is continuous. And then if we were to graph these, and not that these values are exact, I'm just doing a really rough sketch on these. With it being discrete, we know that we're going to have like certain values, right? And if I were to graph this function, and again, this isn't an exact graph, I'm just doing a kind of a rough sketch of it, it would look something like this. And that discrete is each one of those values that is in the sequence, and we're not connecting them. Where on this one we have a function which is continuous, so we're connecting all of our dots. Now granted, when it comes to the definition of a function, the definition of a function is for every x value, there's only one y value. So in other words, like our x's cannot repeat. So technically, when it comes to this one is also a function under the expectation and the definition that a function is where your x values do not repeat. So it's that 1-to-1. The difference between the sequence and the function in this situation is one is discrete and one is continuous. Okay. So when it comes to our values, so like one question could be, let's say, is it possible for t of n to equal 1400? So on this one, they're saying that our output is 1400, and so they want to know if we can have an n value or an input that is 1400. So if we can just kind of make a table if we wanted to, n and t of n, okay? And if we went through and put in some values, like I don't know, let's say if we got to get up to 1400, what's probably maybe a good number to start with? What was that? 5? All right, we'll try 5. So what happens if I put 5 into my sequence? So I would have 2 times 3 to the 5th. So that's going to give me what? 2 times 243, which equals 486. So we're not quite to 1400. So what do you guys want to try? 6? Oh, okay, we'll try 6. Why not? If you guys want to try 6, we'll try 6. So 2 times 3 to the 6th. So that's going to be 2 times 3 to the 6th is going to be 726. And when I multiply that, I get 1,458. So because we know that sequences are discrete, I wanted my little underline thingy, discrete, we know that we can either have 5 or we can have 6 numbers or terms in the sequence, and 1400 falls somewhere in between. So in our sequence, is it possible for it to equal 1400? Nope. No, it's not. Right? But on the flip side of that, is it possible for f of x to equal 1400? And that one's going to be yes, because it's continuous. Right? This is a yes when it comes to our function, because our function is continuous. So we're going to hit 1400 somewhere between 5 and 6. And with it being a function, that can happen. All right. So I think that's a good enough little lesson for today. You guys have an assignment for today. There's a couple problems listed on the web page for section A.3.3. I also threw on a little quiz review on there for you guys. The answers are at the bottom of that. It's optional if you want to do the quiz review. I would highly encourage you to look at it and try to do those and see if you guys can come up with the correct answers. If you need any help, shoot me an email and I'll talk to you later. Bye.